So now let's look at the following example. We're going to use our function y equals x squared we've been talking about. Part A, let's approximate the area under the curve y equals x squared and above the x-axis. Again, we're going with x between 0 and 2 using the rectangles. We said 2 rectangles and the left endpoints. So it's going to help us if we have a picture of our graph of our function. So I'm going to regraph our function that we looked at earlier. Okay. And then in each, so we're going to have a rectangle here from 0 to 1. And a rectangle from 1 to 2. Because remember, the width of each rectangle is 1. And then for the height of these rectangles, we're using the left endpoints in our intervals. So we're going to use this left endpoint right here for our first height. Our height will be 0 for that. And then we're going to use the left endpoint here, make a rectangle right there. And we're going to add up the areas of these rectangles. So the first one, the width is 1 and the height is 0. The second one, the width is 1 and the height is 1. So here you're getting 1. And that's my approximation for the area under the curve here. And I am going to say that if you look, you can tell that this underestimates. This is an underestimate of the area. There's a whole bunch of area that hasn't been calculated by these rectangles, right? This area right here isn't included, and this area right here is not included. So this is an underestimate for our rectangles, or for our area under the curve. Let's see what happens when we use 2 rectangles. And now we're going to use right endpoints. So again, I'm going to redraw the picture of my graph just so I have it to easily reference. And then here's what it looks like. Here's my region. And so again, I'm going to have 2 rectangles, a rectangle from 0 to 1 and a rectangle from 1 to 2. But now I'm going to choose the right endpoint in each chunk. So in this first chunk right here, 0 to 1, I'm going to pick the right endpoint, and that's going to be the height of my rectangle. The same thing for 1 and 2. I'm going to pick the right endpoint, which is 2 here, and then I'm going to make my rectangle. And we're going to add up the area of each rectangle. So the first rectangle has width 1 and a height of 1. The second rectangle has a width of 1 and a height of 4. So we're getting 5 for our estimate of our area. But if you look, we've overcounted the area, right? So I'll say that this right here is an overestimate. Of the area under the curve. Why is this an overestimate? If you look in here, this region right here is not under the curve, and this region right here in blue is not under the curve. And so we've kind of counted too much area now. So our third option for the height of the rectangles is to use midpoints. So let's use 2 rectangles now and the midpoint. So again, I'm going to draw my picture of my graph so that I can visualize these rectangles. 1 and 1, 2, 4. So again, I have 2 rectangles, so I'm looking at a rectangle from 0 to 1 and a rectangle from 1 to 2. And now the height will be the midpoint halfway between in these widths. So halfway between 0 and 1 is 1/2, which means I'm right here. So that will determine the height of my rectangle. And halfway between 1 and 2, that's 3/2. So that'll be right there. And that will determine the height of my rectangle. So I'm going to add up these two. So here the width is 1 and the height, I plug in 1/2 into my function. The width is 1 and then I plug in 3/2 into my function. So my function was x squared, so it'll be 1/2 squared plus 3/2 squared, 1/4 plus 9/4, 10/4, or 2.5. And if you look at this picture compared to the other ones, you'll see that this is a better estimate than either 2 before. Because if you look, you're missing some regions. So here I didn't include that small little region in this one either. But then you also included these regions here and here that weren't underneath the curve. So in some way you've missed a little bit of your area, but you're also over counting some area too. So in general, the midpoints is going to give you a better approximation for your area under your curve.